How do we charge the inductor? S1. If I switch on S1, what will happen? I switch on S1. If I switch on S1, the primary coil of the inductor will be charged? Yes or no? I told you earlier as well. So if S1 is on, the polarity, you can see this dot defining the polarity of this winding. So what we can do, we can have a polarity in this way. So it means the inductor gets charged. Now, for this time period, this switch is open, right? Initially, the inductor is charged when switch is on. Now, inductor will be discharged. So the polarity, initially this dot is there, but once this switch is become open, the energy is stored in the primary coil, it will be transferred to the secondary and dot will be shifted here. So initially it was having plus and minus, now it will be shifted to plus at the dot end, I mean this end, and negative at the other end. So if this terminal will become positive, what happened to the diode? Diode starts, it will be in conduction. Diode, as soon as diode comes into the conduction, this energy stored in the secondary winding, that will be pushed to the capacitor, and then capacitor will push the energy to the battery. Able to get it, this operation? Should I repeat it once again? Should I repeat it? Or you got the idea? Anyone who did not get done? Yeah. So I'm going to explain it again. This converter, because this charger is very famous for low power applications, where low power charger and in some of the electric vehicle as well, we are using this type of charger. So this is really important. So what I told you, the first thing, here we have this VDC, and once VDC is greater than VDC, then diode will conduct, right? Because this is the AC signal. If I'm superimposing this DC, so for this time period only, the diode will conduct, correct? For this time period. So let's suppose this is D1, D2, D3, D4. So if this is D1 and D2, and it is conducting here, and then energy, it is coming to the DC bus and returning back to the D2 and to the source. For positive half cycle. For negative half cycle, it is as it is a full bridge. For negative half cycle, this will be conducting and then it is coming through D3. Now the question is, once this capacitor has the some power, now this power has to be pushed to the inductor. But here you will find out this switch is open in nature. So we have to close the switch. How do we close the switch? Through microcontroller. So we will provide the signal to this switch. So as soon as the switch is on, let it become on, the energy in the capacitor that will be transferred to the inductor, because inductor now start taking the energy as it becomes short circuited with the capacitor. So capacitor, whatever the energy it is there in capacitor, that will be transferred to the inductor. Now next cycle will be there where the switch will be off in this direction. It is on for this direction, off for this direction. As soon as I open this S, the energy is stored in the primary winding that will go into the secondary winding of the transformer, right? So secondary will reverse its polarity. Now the dot will be here and positive terminal of the this inductor will be here. So as soon as we got this positive one, diode will become forward bias, and inductor energy will be pushed to this capacitor. And again, when switch is conducting, primary side is happening, this capacitor will discharge the energy to the battery. This is the basic operation of this particular circuit. This way we are changing the from primary.
Sir, one thing I want to know, sir.
Yes.
All the lithium material charge from the half cycle half wave rectifier.
All lithium and battery. What you are saying? All lithium and battery.
All the lithium material charge through half wave rectifier.
Half wave? No, not at all. Not at all.
Sorry, this is the half wave circuit.
No. Why? This is not a half wave rectifier. This is a full wave rectifier. How do you say this is a half wave rectifier?
One daddy there.
Primary side, you look na. Primary side, it is a single phase system where we have 4 diodes we are using. So it is not a half wave rectifier. Are you able to get it? This is a full wave. For positive half cycle.
Sir, output side is the one that.
This is not output side is DC, my dear. Output side is DC and it is a flyback converter. It is not a half bridge.
Oh, achha.
This is DC to DC. This we are having a DC and this is also DC.
Okay.
Yes, so AC is converted into DC and then DC is regulating through this transformer.
Sir, DC will transfer the supply from transformer to coil. DC. There is a transformer, sir.
Yes, so this is a high frequency transformer.
Confused here.
High frequency. Look, I'm here. Don't worry. I will. Clear your confusion. Yeah, let me know what you wanted to know. What you wanted to know? Where you got confused? First of all, please do remember.
Sir, I confused. One daddy there. So after the DC circuit, middle of the transformer is there. So after
Yes.
transformer and diode, I think this is the half-wave rectifier circuit.
So the diode only it is used to make current in this direction, so that because this is unidirectional charger, remember. So in flyback converter configuration, we use the diode so that when it is become forward bias, so energy can be pushed from this transformer to the battery. But at the same time, this will become reverse bias when this battery try to discharge itself. Try to understand. So battery, any power will not be pushed from the battery to the transformer. Diode is in this circuit. Diode only allow the current when it will become forward bias from inductor to the battery. So when this diode will become forward bias, when the polarity of the secondary winding is got changed, like from here to here. So diode will conduct. Otherwise, diode will not conduct.
So these coils are inductor coils or transformer primary secondary coils?
These are the primary and secondary coils.
Like transformer, not inductor coils.
Yes.
Okay.
No.
Sorry, if a transformer can transfer the signal DC signal to DC signal.
What I told you, this is high frequency transformer, na? High frequency transformer. So this converter is switching on.
Sir, where is the frequency? You have connected diode, sir. Frequency has finished after the diode.
After the diode, no, before this diode, what you are doing? You have a MOSFET here, IGBT.
Yes, sir. I am telling you, sir. Yes, sir.
So this switch.
Yes,
So
sir.
this switch.
Yes,
So
sir.
this switch, it is fired at very high switching frequency.
Yes, sir. The MOSFET is there. Yes, sir. Yes, sir. Clear.
Yes, that's fine. So we have a basic charger power flow block diagram, AC DC rectifier. The function of the AC DC rectifier is also rectified to make the positive input AC and current. They are negative half cycle. Thus the output of the diode rectifier. I mean, this is the simple operation which I described a few minutes back. And then we have DC capacitor charged with the peak voltage when the rectifier voltage below DC, and diode will come into the conduction. And then we have DC converter which converts the high voltage. You can see high voltage on the DC capacitor to save lower voltage, right? Lower voltage 12 volt or some battery 3.5 volt mobile battery might have. So apparent power, you already know, it is a simple multiplication of V into I, and the apparent power has been unit of volt ampere, simple we have, and the real power, the symbol is watt, and one extra term that is coming in this real power, that is cos phi. So simple, we are writing VI cos phi for single phase system. If we are having a 3-phase, so 3 VPH IPH, right? Otherwise, if I taking the this line voltage, so root 3 del IL cos phi, that we can take into the consideration. And power factor we can define as a P by S. Now the question is, when we have these type of charger, so will this a P by S will be there, or there is change in the cos phi? Active power divided by apparent power. What is the change in cos phi if I have a power electronics based load? Suppose diode rectifier followed by capacitor, right? Capacitor. What is the power factor of this? So power factor is not simple P by S. Here the power factor is changed because we have some harmonics in this system. So power factor is changed to distortion factor and fundamental power factor. So fundamental power factor, it will be unity, but distortion factor, it will have 0.9, 0.8 like that. Correct? So power factor, even though the voltage and current are in phase, but you will find this is drawing a very high peaky current in this case, right? High peaky current in such case. So I'm not going to So I'm not going to, take this a simple P by S, but we have to take the power factor as a distortion factor multiplied by displacement power factor here. And then we may have different other topology as well. You can have primary side high frequency, but secondary side we can use the simple diode at this side. So various automotive standard chargers they are also using, because this is a unidirectional charger. Both sides we are using diodes. This side we are using diodes, and this side we are also using diodes. But in between, you will find out the full bridge kind of inverter, I would say, which is converting again VDC into AC. So we have seen how it converts this DC supply into AC, right? So these are the few things. Tomorrow we will start this standard, and we will see the solar-based charging station. That is very important. Today, I mean, I was thinking like I will start today onward this solar-based charging station, but due to these topics are also important. So I haven't covered these. I didn't cover these systems today, solar-based charging station. But definitely in the coming tomorrow, I will try to cover the solar, and then in next class we will cover the wind-based charging infrastructure. So I'm going to stop here. Thank you very much. Thank you for patience listening
Thank you, sir.
and
Thank you.
contributing. Yes, and asking the questions,
Sir,
making the live session.
that time I have asked a question. Hello.
Yes.
But my system got disconnected, so I could not actually listen the answer. But I asked question that suppose some power circuit, some component get failed, then how means it will perform?
So I told you, if suppose I have given a very, I mean, I have given the answer in a very described way. Let me share it the screen again, and then I can give.
That time I got disconnected.
Yeah, no issue. So you can see this diagram. Suppose what I told you, I have switch 1, 5, and down switch were conducting. Let's suppose the switch 2 is switch 5, right? It got damaged. So what will happen? The current will not come from the 5. So current will come from 1, and it is going to the load, return back from the B.
Okay.
Correct? So the converter operation will stop if we don't have minimum one switch which is conducting in the upper as well as lower leg. Though the voltage could be unbalanced, frequency may not be matching with the frequency of operation, right? But if for getting voltage at our output side, we have to complete the circuit, that's all. Right? So even though if one switch got failed, but it should not be like this, like both of the switches are failed from the upside, or one of the switch got failed due to from the lower leg. Otherwise, the circuit will not be completed. Right?
Partially work.
Yes. So suppose one switch is failed. So what you can see the one the current is coming from switch 1, it is going back from this switch B leg, right? Suppose the B leg is failed, the switch of B leg, lower leg is failed. So you don't have any connection with the negative DC bus. So in this way, this converter won't be.
So you have to basically diagnose. So is there any diagnostic software there, or it can?
What?
Suppose in circuits of EV, means complicated circuits. So if some fault come or some erratic behavior.
No, if some converter fault is coming, then we have to replace the switch. We don't have alternative.
So full switch will be replaced.
Yes. If switch got damaged, then we have to replace the full switch.
Okay, that will show in the dashboard. Means monitor.
Yes. Obviously. That will be correct.
Okay. Sir, one more thing that I requested that some development details of battery SOR or RFQ type. You can share. That will be helpful.
Okay, so remind me in tomorrow lecture. I will try to provide. Okay.
Okay. Thank you.
Okay. Thank you all of you. Good night.